Hello everyone, welcome back to the BioDecoder channel where we decode biological data using sample analytical tools. In today's video, I will perform and interpret a multiple linear regression in R, exploring how different weed traits, for example, like plant height and different locations impact weed yield. So let's start by loading our data set named as wheat yield environment dataset. To do so, you simply have to write a command called data and then I have this data into CSV file. You can store it into tab delimited file or any other file, but with whatever or whichever is convenient for you. So I have like my data set into wheat yield environment CSV file. So I will simply load this data set and then I want to see what is inside the data. So for that I will write head, of course you know this, head and then like data, and it will give me a table or column where I have sites. Actually it has like many columns, so what I gonna do is I will select site and then plant height and then we'll see their impact on grain yield. So it has like many traits. For example, it has site, it is genotype, plant height, spike length, grain per spike. I will use yield per hectare as well as plant height and site and the of course maybe later treatments. So what I will do is I will use plant site and sites like different locations as a predictors of yield. So let's begin. Now we will fit the linear model using LM function and check the summary. So to run this model, we need to write a simple and very easy script, and it is called model LM, linear model. So LM is for linear model. Y is yield is like dependent variable, and these are independent variables like plant height and site, and then this is the data tab for data. So we will run this model, and then to run this model we need to simply click on this model, and then we need a summary table. So here we go. Here, so let me bring this up. So we got a summary of this model. So let's now interpret decode these results. So here, this is like important column. Here, this table will tell us which variable is impacting yield or which independent factor is impacting yield. So, and if we change yield by 1 unit, like if we change any variable like independent variable by 1 unit, how much crop yield will be impacted. So here we have the intercept value is 8.97 almost, so it's a 6.8, so we consider it like 8.97. This represents the baseline yield at the reference site. So this reference site is another site, like it is Lahore, like in my case. So it would be like by default or consider one first site or first variable as a baseline. So baseline yield means baseline at the reference site when, so it considered that plant height would be 0. So I guess I conveyed my message. So it is like baseline yield when we consider plant height as 0. So this is how we define the intercept. So then the plant height coefficient is 0.05489, okay, with p value is less than 0.0001. So this means that for every 1 centimeter increase in plant height, the grain yield will increase by about 0.5489. And it is like it has positive value, so we are saying increase. So if it has like negative value, then we will write decrease in the yield. So this means if I want to interpret this as what would be the impact of plant height on the grain yield, I will write it in my paper as that with every 1 centimeter increase in plant height, the grain yield will increase by 0.05 tons per hectare. In my case, the unit is tons per hectare, and this, like, this is a quite significant impact on. So this shows that the plant height has a significant impact on grain yield. So this here, so this side factor. So since we in model we used plant height as well as side factor. So it means that Faisalabad's yield is 1.47 tons, or almost 1. Since it's 69, so it's by rounding about, it's like 1.47 tons per hectare lower than the reference site. So reference site here, I mentioned that in my case it was Lahore. Otherwise, your might be different. Your might be a site or treatment or species, whatever you have. So here I have my yield is less than 1 point less. How much less? 1.46 tons per hectare. So this much is lower than our reference site, and this difference is also statistically significant. So if you see here, this value is lower than, and we got the 3 stars, and 3 star is like less than 0.0 or less than 0. So if we interpret the result for site Multan, so same is the case here. The yield is like 0.57. So here 0.5% lower than our reference sites, like from our intercept, but is statistically not significant or non-significant. So this is the difference between Faisalabad and Multan. So then here in this, like here it is telling us what is the residual and what is R scale. So important thing here is our this value, R scale value. So the multiple R scale value is 0.292966, meaning that both our factors, like both our independent variables, like plant height and the site, they together explain about 30% variation in grain yield. So they are contributing 30% variation in grain yield. So I guess it's quite reasonable for biological field data. I guess it's a very good, result, and they are. So next, let's perform the ANOVA. So to do that, you simply need to write ANOVA, and then we have model. So right here, ANOVA, and then we have a model, like our data set. So here's the ANOVA table. So it's like, of course, it just justifies that what we have in regression model. So both plant height and site are highly significant. Here you can see both confirming that taller plants. So what does this means actually? It means that taller plants and location difference has strong impact on wheat grain yield. Since both are significant, so it means that plant height, it has significant impact on yield, and then we planted those wheat genotypes at different sites. Those sites differ significantly among themselves. Okay, so this was like kind of basic overview of regression analysis and how can we interpret and check the results. And then another thing what we do and what reviewers mostly ask is to check the normality of data. For that, we normally plot a QQ plot. So this is it's a quite straightforward. You just need to write a QQ norm residual model. So it will show you the distribution of your line, and then you also have a straight line, regression line. So you want to see what is the distribution of your sample in the data. This graph QQ plot shows the distribution of your data on the straight line. Either it's normally distributed or not normally distributed. If you are not sure about that, and if you don't know how to interpret, there is another way to confirm the normality of your residuals. So this is very important. This test, Shapiro test, is for checking the normality of the your data set. So here we got W, which is equal to 0.9827, and then we have a P value here, which is 0.277. So because this P value is greater than 0.05, we fail to reject the null hypothesis, meaning that residuals are normally distributed. So null hypothesis is that the residuals are not normally distributed. So our, so it means that our data is meets the normality assumptions, or the data is simply normally distributed. So this is how you check the normality of your data. If you want to further, like, if you want to make sure that your data, like if you want to check how your data looks like, so you just need to plot a simple histogram. So this is a histogram. So you see that it almost makes a curve. So it's like more or less the histogram, roughly they follow a bell-shaped distribution. So if you see here, from here it goes like here and then it goes down. So it is like it supports our model's validity. So if the data is normally distributed, so it means that we are good to go. We are good to go for our result. So in this video, we have seen that both plant height as well as the site significantly impact the grain yield. So this summary is actually what you need to write in your paper, in your thesis, or in your like whatever you are doing. So in results of your data analysis section or results of your paper. So you need to write that both, in this case, both plant height and site significantly impact the wheat yield, and the model explained about 30% of variation in grain yield is due to the site and the plant height factor, and the data was normally distributed, and both site and the plant height had a significant impact on our grain yield. So thanks for watching Decoder. If you find this tutorial helpful, don't forget to like, subscribe and share. And